Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the details about the motion sensor. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the details about the image sensor. Before going to see what is image sensor, we have to know some basic concepts like what is pixel or what is fill factor. Let's see what is pixel. The smallest discrete component of an image or picture on a CRT screen is known as pixel. Each pixel is a sample of an original image where more samples typically provide more accurate representations of the original. That means, in other language, we can also say that the pixel is the smallest discrete particle or part of the image. Consider, if this is the image, then this is the smallest discrete part of the image, and this box is known as 1 pixel, second pixel, third pixel, fourth pixel, etc. That means our image, suppose this is the image, this is divided into the number of boxes. Each box represents 1 pixel. Okay, I hope you all understand what is pixel. Now let's see what is fill factor. Fill factor refers to the percentage of a photosite that is sensitive to light. If circuit covers 25% of each photosite, the sensor is said to have the fill factor of 75%. The higher the fill factor, the more sensitive the sensor. That means the fill factor is the percentage of photosite which is sensitive to light. Here is this area is of sensitive to light. Okay. Now let's see our point image sensor. What is image sensor? An image sensor is an electronic device that converts an optical image into an electronic signal. The optical image means it converts the light image or the graph of light into its equivalent electrical signal. It is used in digital cameras and imaging devices to convert the light received on the camera or imaging device lens into the digital image. We know that the image sensor is used in mostly the cameras which may be placed on a cell phone, a smartphone, or any digital camera. Okay. An image sensor is used to detect and transmit information for making an image. These sensors are used in both analog and digital type electronic imaging devices. The analog sensor which are used in the past are video camera tubes. At present, semiconductor CCDs means the charge coupled devices is used. Otherwise, active pixel sensors within CMOS. CMOS means complementary metal oxide semiconductor technologies is used. That means in past the image sensors are used in the form of video camera tubes, but nowadays these video camera tubes are replaced by semiconductor CCDs and CMOS technologies. Okay, analog sensors are vacuum tubes, whereas digital sensors are flat panel detectors. These are the basic information about the image sensor. Now let's see the types of image sensor used in nowadays. There are two main types of image sensor. First one is charge coupled device, that means CCD, and second one is complementary metal oxide semiconductor, that means CMOS. This is CCD image sensor and this is the CMOS image sensor. Now let's see the more details about the types of image sensor. The image sensor consists of two-dimensional array of thousands of discrete pixels. We know that the pixel is the smallest discrete part of the image. Okay, the amount of light on this pixel generates free electron. As the amount of light falls on this pixel, the light converted into the electrons. Okay, the quantum of charge depends on the intensity of incident photons. Both CCD and CMOS depends upon the photoelectric effect in order to create electrical signal from the incident light photons. That means both CCD and CMOS depends upon the photoelectric effect. We know that the photoelectric effect states that it converts light energy into electrical energy. This light is incident on this pixel. This pixel contains the material which is sensitive to light. That means there is a conversion of light energy into electrical energy in the each pixel. Okay, both uses different technologies in order to capture digital image. Both the sensors differs in conversion of charge into voltage as well as readout of the chip. That means both the sensor CCD and CMOS uses the photoelectric effect. The photoelectric effect is the light energy converted into electrical energy. That means both the sensor CCD and CMOS contains the photosensitive material in each pixel. Okay. Now let's see the details about the charge coupled device CCD image sensor. The CCD transfers each pixel charge packets sequentially to convert each charge to a voltage. In CCD, the generated electrical charge is converted into the voltage. Okay, the CCD consists the array of thousands to millions of light sensitive elements known as pixel etched on silicon surface. In this diagram, we can see here that each box represents one pixel and each pixel is made up of the light sensitive element, that means the photosensitive element which is placed on the silicon surface. Each of the pixel is buried channel MOS capacitor. Okay, the CCDs are fabricated using P-type substrate and buried channel is implemented by forming N-type region on this surface. That means in the construction of CCD, these are fabricated using the substrate which is made up of P-type semiconductor material and the buried channels are made up of N-type region. That means there is a PN junction generated, and when the light incident on it, then the hole and electron pair takes place and the charge appears. Now further this charge is converted into the voltage. Okay, the size of CCDs are specified in megapixels. A megapixel value is equivalent to the multiplication of number of pixels in row and number of pixels in a column. Okay, that means whatever the number of pixels in row, these are, suppose these are m pixels in row and n pixels are in column, then the megapixel value is given by m into n value. I hope you all understand the things here. Now let's see the working of charge coupled device CCD image sensor. The CCD sensor is a silicon chip that contains the array of the photosensitive sites. These are the photosensitive sites. Okay, each pixel contains a photodiode. Okay, the image capture process begins in the photoactive region of each pixel. A CCD operates as a network of analog shift register. We have seen the details about the shift register. The shift register is an electronic component which is used to store the digital data, and it is mainly used to transfer the data from one register to the another register. Okay, there are two types of shift registers are used: horizontal shift register and the vertical shift register. A horizontal shift register moves charge packet from one line of the sensor to the output. Okay, this horizontal shift register moves the charge horizontally towards the output. When that line is complete, vertical shift registers move charge packets up for the next line into the horizontal shift register, which then performs readout. That means after completion of shifting the first line data, the vertical shift register gives the next bit or the next data to the horizontal shift register, and then again the horizontal shift register transfers the data of second line. This process continues with the thousands or millions of the little charge packets matching around the sensor until every last one has been converted into a voltage and delivered to the external signal processing circuitry. That means, in short, we can see here the working of the charge coupled device. That is, when the area or the CCD is exposed to the light, then each pixel contains a photosensitive material. When the light incident on it, then it has some specific value of charge in it. This value is stored into the vertical shift register. In first line, the data is transferred towards the horizontal shift register, and when the completion of data takes place, the horizontal shift register transfers data towards the output. Okay, when the transmission of first line is completed, then the second line data, that means the vertical shift register, transmits the second bits towards the horizontal shift register, and then the second line is transmitted towards the output. This process is continuous till thousands or millions of time. I hope you all understand the working of the charge coupled device. In order to record images in full color, a Bayer's color filter array is bonded to the sensor substrate. This filter array is made up of alternating rows of red green, that means this red green, and blue green filters, that means this row is made up of red green, and this row is made up of green blue. This one again is red green, and this one is green blue. That means there is the alternating rows of red green and blue green filters known as the RGBG filter. A particular color filter allows photons of that color to pass through the pixel. The EMCCD, that means electron multiplying charge coupled device, is used in place of traditional CCD to overcome its drawback. Okay, these are the basic things about the charge coupled device. There are three types of charge coupled device. First one is the full frame transfer, second one is frame transfer, and third one is interline transferred CCD architecture. This is the interline transfer CCD architecture, this is full frame transfer, and this is frame transfer CCD architecture. Now let's see the second type of image sensor, complementary metal oxide semiconductor or CMOS. In CMOS sensor, the charge from the photosensitive pixel is converted into voltage at the pixel site, and the signal is multiplexed by row and column to multiple on-chip digital to analog converters DACs. That means in complementary MOSFET or complementary metal oxide semiconductor sensor, the charge is converted into the voltage into the pixel. Okay, and there is also the amplifier in it. Inherent to its design, the CMOS is a digital device. Each side essentially a photodiode. That means each pixel is having a photodiode, three transistors. That means the amplification circuitry performing the functions of resetting or activating the pixel amplification, and charge conversion, that means analog to digital converter, and selection or multiplexing. That means the difference between the CCD and CMOS is the CCD contains only the photodetector, but here the CMOS cell, each pixel contains a photodiode as a photosensitive element, analog to digital conversion, and also the amplification circuitry. Okay, this leads to high speed of CMOS sensors, but also low sensitivity as well as high fixed pattern noise. Okay, this is the two types of CCD and CMOS sensor. Now let's see the difference between CCD sensor and CMOS sensor. The first feature is full form. CCD means charge coupled device, while CMOS means complementary metal oxide semiconductor device. The second feature is susceptibility to noise. In CCD sensor, the susceptibility to noise is less, while in CMOS sensor it is more. The sensitivity of CCD sensor is greater, while that of CMOS is lower. The power consumption of CCD is more and CMOS is less. The battery life of CCD is short and CMOS is long. The manufacturing of CCD requires specialized assembly lines, while the manufacturing of CMOS is easier. The cost of CCD is more, while the cost of CMOS is less. The architecture used in CCD is passive pixel sensor, while architecture of CMOS is active pixel sensor. The readout mechanism of CCD is serial, while that of CMOS is parallel. The speed of CCD is lower and the speed of CMOS is higher. The application of CCD is used in cameras offering excellent photosensitivity with focus on high quality and high resolution images, while the applications of CMOS sensors are these are used in cameras offering lower photosensitivity, low image quality, and low resolution. That means CCDs are used in high resolution and high quality, while CMOS is used in low resolution and low quality. Now let's see the advantages of CCD image sensor. The conversion takes place in the chip without distortion. The CCDs have very high uniformity technique for HD quality images, not for videos. These sensors are more sensitive, that is, they produce better images in low light. CCD sensors produced cleaner and less grainy images, that means they produce low noise images. CCD sensors is produced for longer period of time. Now let's see the disadvantages of CCD image sensor. The CCD sensor consume much more power. They are interlaced and inferior HD videos, that means less pixel rate. CCDs are very expensive as they require the special manufacturation. Okay, now let's see the advantages of CMOS image sensor. The CMOS consumes less power. CMOS sensors are cheaper. These sensors produce better HD videos. CMOS cameras are used on phones, tablets, etc. CMOS imager clearly has better performance. Now, let's see the disadvantages of CCD image sensor. CMOS sensors are also more susceptible. Sometimes images are grainy. CMOS sensors need more light for better image. These are the advantages and disadvantages of CCD and CMOS image sensor. Now, let's see the applications of image sensor. The image sensors have the very wide range of application, like it is used in space and military, in automotive, in medical field, in security and surveillance, in biometrics, in digital cameras, in mobile phones and personal digital assistants, in digital video cameras, in barcode readers, in toys, etc. That is mean it is used in digital cameras, PDAs, camcorders, that means video recorders, toys and robots, fingerprint scanners, virtual keyboards, etc. I hope you all understand all the details about the CCD and CMOS image sensor. Thank you.